soul should dwell in any other shape than ours. You could be smart, Huygens was saying, even if you looked funny. But he then went on to argue that they didn't look all that funny, that extraterrestrial beings must have hands and feet and stand upright and have writing and geometry, and even that the 4 big moons of Jupiter, the Galilean satellites, were there in order to provide a navigational aid, a convenience for the sailors in the Jovian oceans. Well, maybe.
That bit of speculation is probably wrong, but think of a citizen of the 17th century with the courage and insight to imagine other landscapes and other intelligences. Might there really be mariners on a million other worlds? In his book, Huygens wrote, "What a wonderful and amazing scheme have we here of the magnificent vastness of the universe. So many suns, so many earths, and every one of them stocked with so many animals, adorned with so many seas. How must our wonder and admiration be increased when we consider the prodigious distance and multitude of the stars." The Dutch called their ships flying boats, and the Voyager spacecraft are their descendants, true flying boats, bound for the stars and on the way, exploring some of those worlds which Christian Huygens, a man from Earth, knew and loved so well.
Travelers' tales. One of the main commodities returned by those sailing ship voyages of centuries ago were stories. Stories of alien lands and exotic creatures.
They evoked the sense of wonder and stimulated further exploration. Those tales of strange worlds enabled some Europeans to see themselves anew. There had been accounts of headless people, foot people, cyclops people. Now, the Dutch brought back fantastic stories of giant hunters, dodos, rhinos, leopards, and other creatures.
Modern voyagers also return travelers' tales. Tales of a world shattered like a crystal sphere.
A place where the ground is covered with what looks like a network of giant cobwebs. A world with an underground ocean. Tiny moons shaped like potatoes. A yellow and red pockmarked land with lakes of molten sulfur and volcanic eruptions 300 kilometers high. And a place called Jupiter, so large that 1,000 Earths would fit inside. There are no mountains, valleys, volcanoes, or rivers there, just a vast ocean of gas and clouds. Everything we see on Jupiter is floating in the sky.
But there's much that is fascinating about Jupiter. As the solar system condensed out of interstellar gas and dust, Jupiter acquired most of the matter that wasn't ejected into interstellar space and which didn't fall inwards to form the sun. Jupiter is made mostly of hydrogen and helium, just like the sun. And had Jupiter been a few dozen times more massive, the matter in it might have undergone thermonuclear reactions in the interior, and Jupiter would have begun to shine by its own light. Jupiter is a star that failed. Had it become a star, we would be living in a double star system with 2 suns in our sky, and the nights would come more rarely. Deep below the clouds of Jupiter, the weight of the overlying layers of atmosphere produce pressures which are much greater than any that are found anywhere on the Earth. The clouds are just this little layer here. The deep interior is this high-pressure place. The pressure is so large that electrons are squeezed off hydrogen atoms, producing liquid, metallic hydrogen. But at the very core of Jupiter, there may be a lump of rock and iron, a giant Earth-like world under astonishing pressures, hidden forever at the center of the largest planet. Just before Voyager encountered Jupiter, you could see that giant planet at night shining in the sky, as our ancestors have for the last million years. And on my way to study the Voyager data arriving here at the Jet Propulsion Laboratory, I thought that Jupiter would never be the same again. Never again just a point of light in the night sky, but forever after, a place to be explored and known.
To see the first close-up images of a world never before known, this moment is one of the greatest joys in the life of a planetary scientist.
Yeah, moving that way. We're moving this.
In the early morning hours of July 9th, 1979, on the real-time television monitors at the Jet Propulsion Laboratory, we began to learn about a world called Europa. These are the modern explorers, men and women trained in astronomy, physics, geology, or engineering. Many of them have devoted 5 to 8 years to this single mission.
Cassin's model for Europa says that if you started off with it liquid, you could probably pump in enough energy to keep it liquid.
Let's see. But the Cassin thing said that in order for there to be enough heating going on, you sort of had to start the heating before Europa basically cooled off, as I recall.
Yeah, but Gene, what about the relief from the cracks? Shouldn't the cracks anneal and flow also? They got to be being renewed.
The Io and Europa, there's a twin, a pair there, and then there's a pair out at Ganymede Callisto.
You can't look at the surface of a world so different from ours without wondering how both were made.
Just rotate it out a little bit.
Voyager presented us with 6 new worlds in the Jupiter system alone.
Maybe.
The more you learn about other worlds, the better you understand our own. We speculate, criticize, argue, calculate, reflect, and wonder. We return again and again to the astonishing data. And slowly, we begin to understand. The Dutch sailing ships brought back rare and valuable commodities from the new worlds they visited. Our Voyager spaceships return rare and valuable information to computerized wharves on this shore of the Sea of Space. Here the data are unloaded to be stored, enhanced, processed, and treasured. Maps of alien lands will be generated from this information. In this electronic warehouse are tens of thousands of images of previously unknown worlds. How does a picture from the outer solar system get to us? Sunlight shines on Europa and is reflected back to space, where some of it strikes the phosphors of the Voyager television cameras, generating an image. The image is radioed back across the immense intervening distance of 500 million kilometers to a radio telescope on Earth, one in Australia, say. The telescope then passes the information via communications satellite in Earth orbit to Southern California. There, it's transmitted by a set of microwave relay towers to a computer at the Jet Propulsion Laboratory. And there, it is processed. The picture is fundamentally like a newspaper wire photo, made of perhaps 1 million individual dots of differing shades of gray, so fine and close together that at a distance, the constituent dots are invisible. We see only their cumulative effect. The information from the spacecraft specifies how bright or dark each dot is to be. After processing, the dots are then stored on a magnetic disk, something like a phonograph record. By this day, there were already 11,000 pictures from Voyager 2 in our electronic library.
Finally, the end product of this remarkable set of links and relays is a hard copy which comes out of this machine showing, in this case, The Wonders of Europa.